Okay, hi everyone. My name is Nahi. I'm with you from Toronto, Canada. I hope you had a fun time so far in the conference and enjoyed the talks. Today, I want to talk about how to develop to be compliant with OAuth 2.1 out of the gate. OAuth 2.1 is an in-progress effort to consolidate and simplify the most commonly used features of OAuth 2.0. OAuth community has patched and added to the OAuth spec over the years. And if you want to implement a secure OAuth solution today, it requires reading so many RFCs and best current practices or BCPs. And everyone is now expecting OAuth 2.1 to be out and simplify everything. Today, I want to discuss the details of OAuth 2.1 and the development approach for the current projects to be compliant with OAuth 2.1. In the next 60 minutes, I want to go over the specs to talk about OAuth 2.0 and then the future, which is OAuth 2.1, and then a quick demo using Identity Server 4, which is an open source library for OAuth 2 and OpenID Connect. And then following, we're going to have, I hope that I can leave some time for questions. And but please feel free to reach out on a Slack to chat or for questioning. Okay, let's go back for a second and talk about problems before jumping to the solution. Authentication and authorization are two of main problems on modern web application security. Authentication is needed when an application needs to know the identity of the current user. Typically, these applications manage data on behalf of the users, and authentication.
We cannot see your screen. I think you're expecting us to see your screen, right?
Yep.
We cannot see anything. Sorry.
Oh, okay. I'm so sorry. Nope. 1 sec. Okay. Can you see my screen now?
Yes, now yes.
Okay, cool. Sorry about that. Okay. Yeah, actually, this is the first slide that I wanted you to see in my screen. As I was saying, so authentication and authorization are two of the main problems. And so when it comes to authentication, we want to know, the application want to know who the user is to verify that the user is who they say they are. And like the solution provided for authentication is OpenID Connect or OIDC. And also like these applications that I'm talking about, like which are managing data on behalf of the user, needs to make sure user can only access the data for which they are allowed to, right? Here comes authorization to deal with granting or denying rights to access resources. Here is a big picture of how modern modern web applications may look like. And each and every one of these components or these applications which are on the screen are to protect resources. And that's why they need to implement authentication and authorization. So I have this big picture and putting the solutions in place in them. And if you see like in this picture, like for example, browsers communicate with the web applications, and like browser-based applications communicate with web APIs, and APIs communicate with each other or with web applications, but like they can connect on behalf of the user or just as themselves. And if you see in this solution, like in this big picture, including the solution, I included the authorization server as well, which is needed for OAuth and OpenID Connect. So this is just a big picture. Let's go to more details, right? So let's see what is OAuth 2. So OAuth 2 is the industry standard protocol for authorization, and it is in fact an open standard. It means open standard means that there is no implementation for it. There is some standard that it is suggested to how to implement So OAuth is a delegation protocol, which means someone who controls resource and allows a software application to access that resource on their behalf without impersonating them. Means the user is letting an application to access the resources on their behalf. And this application requests authorization from the owner of this resource, which is the user, and receive a token to be able to access those resources. OAuth is a token-based protocol. And OAuth is working over HTTPS, and as I said, it uses token rather than credentials. OAuth is being developed by IETF OAuth working group, which is IETF stand for Internet Engineering Task Force. So to draw actually a better picture of OAuth, it's necessary to know its terminology first, right? And so I have the list of items in OAuth terminology on the screen. On the left, what you see are the main, and then on the right is just like details of each one. First one comes the roles in OAuth. So we have different roles in OAuth, like including resource owner, which is the entity that can grant access to the protected resources. And typically it is the end user. The client, which is the application, it's the one which is requesting for those protected resources on behalf of the resource owner. And then the user agent. User agent is what user is using to interact with the client. For example, a browser or a native application, like a native mobile app. And the resource server. Resource server are those protected resources that we are talking about, like APIs. And the authorization server, which is actually the main component, as it's the server that authenticates that user and issue the access token to be able to access actually to the protected resources. So like we talked about the client, which is that application who needs to access, right? This client has some credentials. Which is registered to the authorization server. Authorization server knows what is this client. These credentials contains of client ID and client secret. The ID is, as the name shows, is a public identifier, and secret is something that just the client and the authorization server are aware of. So, like, clients have two types: a confidential and also public. Confidentials are those who can keep that secret safe, right? They can authenticate to authorization server securely because they have a safe secret. And the public ones are the ones like mobile apps. They cannot keep the secret safe. They may run in a browser, the public ones. And then scopes and the consent. Scope is used to express what the application can do on behalf of the user, right? And it is always a subset of what user can do. It is used for handling of that delegation that we said OAuth is doing. And the consent is like when the application requests for some scope, this information is shown to the user in the consent form, and user actually can grant or deny. So then the application will receive a token with just granted scopes. And the access token. Access token is the things that this application uses to access those protected resources, to call the API, right? And for access token, it's necessary to say that there is no defined structure in the spec for that, but the most common use is bearer tokens, which are mostly JWT or JWT. The grant types. Grant types for OAuth is the different use cases. It's just the use cases which are implemented in OAuth are provided as a grant type. So some of them are in the BCPs or best current practices. Some are suggested to not be used. And but OAuth 2.1 is actually making like more concrete suggestions about this. So here comes client credentials, authorization code, and proof keep for code exchange or PKCE, and the password and implicit. So between this, the client credential and PKCE are the ones which are now suggested to be used on OAuth as well. But rest of them are still compliant with OAuth too. And the endpoint, which is like the authorization endpoint and token endpoint. First is to just interact with the resource owner and get the grant, and the token is actually to receive the access token. And the last is refresh token, which is allowing the application to obtain a new access token without prompting the user. So here was the terminology. So it is necessary to know, to understand what the flow is. And then later we're going to talk about now what is the next step, which is OAuth 2.1. But without this is like we need this knowledge to go to future. So here is the abstract protocol flow, right? And all the components I showed, like we talked about in terminology, you can see them here. This is abstract, obviously. There is no grant or use case here. So as you see, we have the resource owner, we have the client, the authorization server, and resource server. And it's just showing in an abstract way that how they interact with each other as we talk. And now what is OAuth 2.1? Now that we know like the concept of OAuth 2 and the terminology, and now we are ready to go. Like what is OAuth 2.1? It is an in-progress effort now, which means that it's not out. And if it's approved, so it's going to obsolete some certain part of the OAuth 2.0, including some of those grants, and mandate additional security best practices. It is, and the rest going to stay the same. So it is here, it's going to be here just to simplify and provide a better, more concrete way for developers to simplify their life. And here is the big picture that I showed you. Once OAuth 2.1 is out, like it's going to be like this, means that wherever that we have OAuth 2.0 going to be replaced with OAuth 2.1. So nothing is expected to change as far as we know about this. Okay, now what are these changes that are suggested in the OAuth 2.1? The first one comes with PKCE. So it says PKCE is required for all OAuth clients using the authorization code flow. So like in OAuth, there was BCPs and some RFCs which was saying that just use PKCE for like a public client, but in OAuth 2.1, it is actually required for all all the clients using authorization code flow. So let's see first what is authorization code flow and what is wrong with it that PKCE is suggested to be used. Here I have authorization code grant on the screen. So it was originally suggested for mobile application, but now it is actually used by confidential and public clients. So the base of this grant is to exchange the authorization code for an access token. What does it mean? So this flow has two steps. So first one is in front channel, which is less secure, and it is via, like for example, browser. So which in this step, there is a call for the authorization server, and it results in authorization code, which represents the outcome of this front channel operation, right? So here you see on the screen on the right, so the first call which is happening. After that, the user returned to the client via the redirect URL, right, which was passed in the first call, and then application gonna get the authorization code from the URL and use it to request an access token. So the second call is a back channel, which is highly secure one, and in this step, there would be an exchange of this code, which received in the first step, with the access token. So on the second step, the confidential clients need to send their secret, but for public ones, as we said, they don't keep the secret safe, so they won't send the secret, right? But what is wrong with this, right? So why it is suggested to use PKCE on the top of that? Because it looks to be like something good, right? Good enough. But like there is some common attacks on the authorization code flow. The first attack that I'm showing you is about stolen authorization code. Which is for public clients, which is very common for public clients. What you see on the screen is an example of authorization code interception attack, which is happening on the smartphones, right? So because public clients which don't have a secret, it seems if a malicious app steals the code, it can exchange it with the access token and abuse the protected resource, right? As you see on the screen, in this smartphone, it is possible to register a malicious app alongside with the honest app and just receive the access code and then try to exchange it with the access token because there is no secret involved as well. In this case, so this is for public clients. So next attack I'm going to talk with you about is authorization code injection attack. This is an attack which is not so common, but it is happening, and it is common. I mean, it is happening for the confidential client. This attack is actually very hard to visualize and draw pictures, so I'm going to try to explain it. That's how it works. So in this attack, as like the attacker obtained the authorization code actually by intercepting it. So just imagine in this attack, the attacker and also the honest app, they are actually using the actual client. Means that the attacker have a machine with the actual client on it. But then the attacker obtained the authorization code by intercepting. Like, for example, just imagine having a like malicious browser extension installed on the honest client. So then the attacker perform a regular OAuth authorization process with the legitimate client on their device. And then the attacker injects a stolen authorization code, which was from the honest client, in the response of the authorization server to the legitimate client, right? So the client sends the code to the authorization server's token endpoint along with the client ID, client secret, and actual redirect URI, right? The authorization server here, what does it check? It checks the client secret, it checks whether the code was issued to the particular client and whether the actual redirect URI match. And all of them actually matching here. So if all succeed, which does, the authorization server issues access and other tokens to the client, right? And now the attacker is able to impersonate the legitimate user. So, and this is the attack for confidential clients. So, and now we prove that, like we tried to prove that authorization code flow is not safe for public and also confidential client. Here comes PKCE. PKCE, or proof key for code exchange, was suggested originally for public client, but as we discussed, now it is suggested, or it is actually mandated by OAuth 2.1 to be used for public and also confidential clients, right? So what does it do? So PKCE, in simple word, it just introduced a random secret created by the calling application that can be verified by authorization server. This secret is called the code verifier. And additionally, so the calling app creates a transform value of the code verifier called code challenge and send it over HTTPS to receive the authorization code. You see on the screen on the right where I am showing the calls that the code challenge that we talked about is sent actually to get the code, right? And later, when it is asking for exchanging that code with the access token, it's going to send the verifier, the plain one, to the server. So then with PKCE, with this maintenance happened on the authorization code flow. So the code challenge and code now are tied together, right? So it means that if they don't match, the server would not return the access token. So PKCE actually protect against CSRF or cross-site request forgery as well, with the same mechanism that it used. So it's like, just imagine that as every time it's like a one-time secret, and every time the client is authenticated. And so far, it is actually protecting against the attacks that I explained. So on the PKCE, so you see on the screen, you see on the first call redirect URI, right? So the next suggestion is about that redirect URI. It's a redirect URI must be compared using exact string matching. So this means that the authorization server must utilize exact matching of the client redirect URI against the pre-registered URI, right? So the wildcard is actually compliant with OAuth 2.0, but now with OAuth 2.1, it wouldn't be compliant. And so here I have actually a couple of, I have these URLs showing you that, for example, if the registered one is a wildcard one, so the valid and also the attacker both gonna work, right? It's like having exact redirect URI gonna help to detect mixed-up attack as well. Mixed-up attack is actually a very complex attack, but it comes in a picture when a client needs to deal with different authorization servers, right? The next change suggested is about implicit grant. So it says that the implicit grant is omitted from the specification. So what is this implicit grant? So it was previously recommended for interactive clients without a secret, like a JS client, like a JavaScript client, right? So the primary reason that implicit grant came to picture was because of a limitation in browsers, right? They couldn't make a cross-site AJAX call, and normally the authorization server is hosted on another domain, and they couldn't do that initial post, which was required for authorization code flow, right? But there is no more issue anymore because nowadays it's fixed with CORS, and they can do actually cross-site AJAX calls, right? So, but let's see what is implicit grant and then why it is not to be used. So if you see here on the screen, so I have the calls happening on the implicit grant. In implicit, to just simplify, to remove that post that we talked about on authorization code, it's just there is a call simply to the authorization server asking for the token, and just return the token, the access token, in the URL back to the client, right? So if this way, there is a couple of actually damages may happen. First of all, the token can leak because the token is returned in the URL, right? It can leak on log files, browser history, referrer headers, and proxies, and wherever that, whoever can access this URL, like any other JavaScript which is on the browser, they can access this token, right? And so it also can cause access token injection. So this is about injecting a stolen access token into a legitimate client on a device under the attacker control, right? And in this attack, actually the attacker wants to impersonate a victim and cannot use their own client because they want to access certain functions on this particular client, right? So, and because this spec actually was not originally safe, so the spec provides no mechanism to return like a refresh token, and it's suggested to just have the very, very short lifetime, and also limited the scope on the implicit. That's why now it's on OAuth 2.1, it would be gone for good. The next thing which is omitted from spec is actually the resource owner password grant, or some may know it as a password grant. So this grant is insecurely exposes the credentials of the resource owner. And also it just brings this bad habit that user insert their password all over the place and not just in one unique place, which is the authorization server, right? So here is a password grant. I tried to show you that how simply just the username password of the resource owner is actually sent over the authorization server. So it is actually against the main, it was there for migration purpose originally, and it's against one of the main concerns of OAuth, which was password, avoiding password anti-pattern. The next change is actually about the bearer tokens. So bearer tokens, as we said, are the most commonly used access token types. So it say that bearer tokens shouldn't be used on query string of URI. As we saw on the implicit, that's exactly what was happening. That's the implicit going to have problem with this fact as well, right? So bearer tokens, as we said, they are known, also known as access tokens. They actually let us to access the protected resources, right? So most tokens are JWT or JA, and but originally when the OAuth came out, they were allowed to be on the header, on the post bodies, and also on query strings. But now it is actually prohibits, the spec prohibits the bearer tokens from being sent in the query string. And as we said, the query string and more generally any data in the URL is never private, and any JavaScript executing on the page can actually access that. It can actually leak in the log files, as we said, in the cache, in the browser history, and in general, if you want to pass information privately over the internet, use TLS first, which is the key, and also put the sensitive information in the post body or HTTP header and not in the URL. So here comes the grant types limited for OAuth 2.1. So which are limited now to client credentials and PKCE. The last point is about refresh tokens. Refresh tokens allow a client to retrieve new access token without re-authentication, right? So the OAuth 2.1, it say that refresh tokens for public clients must either be sender constrained or one-time use. What does this mean? So let's first see what is refresh token. How does it work, right? So here is actually an abstract picture showing how refresh tokens works, right? So like when we get a token, there would be a refresh token in the access token response, and we can exchange that in the first call on the right, as you see. So the client can exchange that for a token, right? On the bottom, under the call, you see the response, right? And in the picture, it shows that as long as refresh token is available to client can actually get another refresh token, and this cycle can go forever. So then if the refresh token leak, so it may bring very huge damages to the system, right? For confidentials, the secret is required. That's why OAuth 2.1 just mentioned it for the public clients, right? But for public clients, it's there is do two things: one-time password, one-time refresh token use. What does this mean? It means that after refresh token is used to retrieve the access token, it becomes invalid. Means that if there was a leakage, it would be abused just once, and there is a hope that client because just imagine an attacker intercept the refresh token, and then they try to use it. And then after that, the honest client trying, and they get error, and like they're going to get notified that something wrong is happening, right? And the second thing was about being a sender constraint, right? It means that ensure it's for the authorization server to ensure that the refresh token and client are bind together cryptographically. So it means that each client can ask for a refresh token and the same client can use that, right? So, and it ensures that the request came from the client to which the refresh token was issued. So there is multiple suggested implementation for this, including like using OAuth token binding or mutual TLS authentication. I am gonna actually, I want to try to explain the token binding for refresh tokens. It's interesting for me. So like for token bindings, there from left to right, there is two calls involved, right? If you see on the left, so you see like a normal post to get token, to exchange code for token in PKCE, right? So here, but there is in the token binding actually in the spec introduce a new HTTP header named security token bindings. You see it in the picture that once client is asking for the access token, it actually set that header, right? So it is it is carrying a base 64 URL encoded value for that token binding message, which just client is aware of, right? And then it gets the refresh token. And the next time when the client wants to actually exchange this refresh token with an actual token, it sets the same value in the header, right? So this means that like in the first call, the authorization server has bound this refresh token to the provided token binding ID from that encoded message in the header, right? So, and when we do this enhancement, the response may look like the one on the right, on the bottom, and because and just having access token, because now refresh tokens can be long-lived, right? Because they are safe and they are bound to the client. So we actually went through everything about OAuth 2.1. Now, I want to actually talk about the OpenID Connect and what's going to happen to OpenID Connect. So OpenID Connect, just to just give you a better picture, is the open standard for authentication, right? It actually came in the picture as a simple identity layer on the top of OAuth, and is extending OAuth 2.0 for authentication scenarios. It is developed by OpenID working group, the OpenID Connect, and I tried to show in the picture that OpenID Connect actually stand on the top of OAuth 2.0. So on OpenID Connect, there is some new concepts like ID token, which is a JWT as well, contains scopes about the user, the current logged in user, and also the user info endpoint, and which return the data about user. There is some standard for scope, and also there is some standard for implementation as well, which suggests how to implement OpenID Connect. And here is a big picture of how it works, and just to show it is on the top of actually OAuth. So I'm not going to dig into OpenID Connect. I just wanted to show you that as far as we are concerned in the scope of this session, so it's just the future of OpenID Connect is that it would be the same thing, but on the top of OAuth 2.1. Okay, so I am done with my slides. I'm gonna actually show you a quick demo I want to show you a quick demo using Identity Server 4, which is an open source library for OAuth 2 and OpenID Connect. Just bear with me for a second to be able to actually share my screen with you. Okay. Please let me know if you have any issues in my screen. Okay. Here I have on my demo, I want to actually show you a couple of these grants that's like I showed you on OAuth 2.0. And then as far as we are concerned, like the implementation has no change, just there is some enhancement which we need to do. So here on my demo, I have a demo ready for you. So it contains of Identity Server, which is actually the authorization server. I have a couple of clients ready. I have an API, which is our resource, right? And for the clients, I have some public clients, which is a Razor client and a JavaScript client, and also a confidential, which is MVC client. So I want to show you simply how simple it is to actually log in using the OAuth, right? So here I have my API running, and here is my JavaScript client, right? So I'm gonna actually show you the network as well. So on my I'm not intending to show you how to do a good UI or something like this. It is just a very simple demo just to show you like PKCE. So here on my JavaScript client, what I have done is very simple. I came and then I registered my client, right? If you see here I have my JavaScript client, which is simply register. So I mentioned that the grant type that I'm going to use is the code, authorization code, but also I said with enhanced PKCE, right? And I am saying that I need a consent also, I say that this is a public client, means that there is no need for a secret. And the redirect URI, I registered the exact URI, means that there is no wildcard. And if it wouldn't work with any other URI, right? So here, I come here, I say, okay, do a login. And then when it comes to login, it actually redirects me to first clear my... Okay, so I say, okay, just do a login first. So when I'm trying, like as you see, I am redirected to the authorization server. This is what we want to see, a unified login string on the authorization server. And I will try to log in. And once I logged in, I see the consent, right? So and then I am allowing here, and then it is a logged in state. And then now, if I try to actually call an API, it is called. Here in the screen, I wanted actually to show you something. So like if you see, like in case of security, so okay, I want to show you the token, right? Here is the token call. As I mentioned, it is done on back channel and it is secure. There was a post and there would be no leakage of nobody can see that what is happening, right? So, but this was a public client. And I have actually a private client, a confidential client here available as well. So for this one, it showed logged in because the identity server obviously is logged in. And okay, now because I actually forced that, it asked me for login. And again, so here I am logged in and I can call the API sending the token. So like I want to actually show you the difference between that confidential client and so here is my confidential client. As you see, my confidential client is exactly same registration, but what is happening is that first I have client secret registered, and also like I'm using PKCE, but I didn't say no need for secret, and also the return URLs, right? So to show you like a tiny bit of tiny bit of how to go from implicit to the code with PKCE, I actually made two clients ready for you. So first is the implicit, and the second one is using code flow using PKCE. So if you see here, I'm showing you simply the registration, that how easy I could go from implicit. I'm going to show you the clients as well. So from implicit to the code flow with PKCE, right? So this one is implicit and it doesn't mention the require PKCE, and also it doesn't need to say that require secret is false. But here, all I did was to change the flow to code and also saying the PKCE. Now I'm going to show you actually the actual client code. The Visual Studio is unhappy. It's acting weird. Can I stop it? Okay. So here is my Razor client. The Razor client that I have using implicit, all it does is that, okay, now I want to use the identity server. Like I'm logging using OpenID Connect. It's just saying that, okay, my authority is that authorization server I showed you, and this is my client ID, and that's all, right? But then, like when I did that client with PKCE, so what I did, the enhancement I did, which wasn't very hard, was to just say, okay, now the response type now is code. That's all. Everything else is managed by the library. So the main purpose of me showing you this demo is to show, if you pick a proper library, if you pick the proper service provider, how easy it would be to implement this. And developers that are developing the applications or the APIs are not the ones dealing with all the specs, right? So they are the ones to just make sure that the library or the service that they are using is actually providing all the required and suggested things in the spec. The other thing I wanted to actually show you is the refresh token, and just show that how to have a refresh, how to retrieve refresh token and how to use it, or how to use the bearer token to call API. Here I've got my API, my MVC app, which is logged in. So here I am in my controller. If you see, I can, in using .NET 5, it's so easy. Like now I have the refresh token available, which I could actually use it. I have my ID token, as we said, for OpenID Connect, and I have my access token, right? Here, simply what I'm using is to just put that access token in a bearer and call an API. I put it in the header and I just call the API, and this is there. So the other thing that I wanted to show you was about the consent. So when I log out, and then when I log in again, So what I'm going to do is that in the consent, for example, I say I don't want the user to have this access, right? So here I go here, and then now if I try to call an API, I can't because I don't have the access. But this user, in fact, it originally had the access, because if I just provide it to them, so what is happening is that if I call this delete API, it's going to work. Means that it's just to demonstrate how to remove, like simply remove a scope or an access from user using the consent form. As far as I am concerned, I'm done with demo, but like I want to leave some time for questions if there is any. Please unmute yourself if you want to ask any question, or if you want me to show you anything in the code. I know the code part is more interesting part, but like feel free to just show me if, tell me if you want me to show anything in the code. Okay.
Thank you so much.
Hi there.
Hi.
My mic, I have to keep my hand on the space bar so it keeps picking up. I was just going to ask with regard to the clients, do you think in Auth 2.1, I'm just trying to work out whether, I kind of asked a similar question in one of the earlier sessions, it was about Blazor and Auth 2. What I'm trying to figure out is whether you think that in the future, is it kind of appropriate that public clients should hold, like ID tokens and access tokens themselves, or do you think it will go in a direction where public clients will be forced to have a private backend and session management will live between those two, and all the ID tokens and the access tokens will stop in the in the private part of the application?
Oh, you said that you like Blazors, right? Blazor applications and for the future. Is that what you said? Yeah.
I guess for any public client, I guess.
So I don't think that the future going to be to have actually like a server in between like MVC. So I believe the public clients and like browser-based ones, they are intending to stay browser-based and to be more secure, not saving things on the client. Like the access token and refresh token, you mean, right?
Yeah, exactly.
Yeah. So to be safer, like I don't believe that the direction going to be to save them. Actually, to have like something in between as an intermediate, like a server side thing to save stuff. Like it would be more to not saving anything on the client and just buying more overhead. But this is actually a very, very subjective thing, right? It depends to your client. Like for example, for the ones that you want more security, maybe you just buy that overhead and you say, okay, I want slower one, not saving and just going through server to retrieve an access token every time, rather than for the ones that like the security is not that big of issue, and you say, okay, I want to just save it and just deal with the damage it may bring.
But in the public client, if you didn't save anything on the public client, how would you keep having to go back to the identity provider to get the ID token every time you wanted to initiate a request for an authorization?
For the ID token? For the access token, right?
I guess, were you saying that you thought that the public client shouldn't persist either the ID token or the access token, or you say?
No. What I'm trying to say is that it would be dependent to the client. If they want very, very secure things, yeah, they may develop to just go to the server every time. But this is, as I said, this is totally depends to the business and to the client. But as far as like I know, the direction is to just keep that in the client, and keep the client in the browser and not having something on the server.
Okay, thank you.
Okay, I guess that's it. Thank you so much.